All right, so we are wrapping up our chapter on expressions. Okay.
Yay.
So what we're doing today is you're going to see we are actually going to use every single or almost every single skill that we have learned so far in this chapter in this lesson. Okay. As a matter of fact, you're going to see the way some of these problems are written are going to be just like the problems on your test next week. All right. So what we're going to do today is we are going to take and justify equivalent expressions. Believe it or not, we have done this before when we did our properties worksheet. We only, though, justified with actual properties. Now we're going to justify with not only properties but other things as well. Okay. So here we go. I'm sure most of you guys already have this with your name, date, and period up at the top, so make sure you have that. All right, let's go ahead and let's start at the very bottom on problem number 3. Okay, now actually before we do that, it's probably important to go back up to the top, read our directions. All right, so here we go. Let's close read them. Complete each
Table.
Use an operation or
Property.
to justify each step. Okay? So, looking at problem number 3, they ask us a question. It says, are the two expressions equivalent? So if we take a look, here's what it's talking about. It's talking about this really long expression here, and it's talking about this expression on the other side of the equal sign. Okay? So we don't know if it's equal. That's what they're asking us. All right? So we want to know, are these two expressions equivalent? So here's what they do. They set up a table for us. All right? We're going to use this table to actually simplify, solve this actual question here and to be able to give an answer, bottom line. Okay? So here's what we're going to do. If we go step by step, step 1 is, what we're going to do is we're going to take this expression here and we're going to rewrite it. This little chunk of space is where we're going to show our work. So we have 3 times and then the difference of x minus 5 plus 12 times the sum of x plus 3. Okay, now here's what we're going to do. First off, you have to realize this whole expression here, ultimately we're going to simplify it to see if it matches this, okay? This is not simplified. How do I know? Well, remember, the two conditions is a simplified expression cannot have parentheses and it cannot have like terms, and we have both going on here. So when we simplify a long expression like this, our first thing we're going to do as a 7th grader is we're going to actually eliminate parentheses. So this leads us to step 2. Okay, step 2 is we are going to simplify, but we're only going to start by doing one thing to simplify it. We're not going to get it all the way to a total simplified answer. We're only going and doing one part of it to start with. Okay? Now, the part I'm looking at is the fact that there are parentheses, okay? And we have to get rid of those. And what I'm looking at is I have 2 sets of parentheses. Well, just looking at this, right? If I was to simplify that, I'm going to use distributive property. Right? That's what we've talked about in this chapter. So I'm actually going to do it with that and with this. So here we go. I'm going to focus one at a time. So here we go. I'm looking at this part of the expression. It's 3, an x, and a negative 5 inside the parentheses. I'm going to go ahead. I'll use rainbow method here. I'm going to multiply. 3 times x gives me 3x. 3 times a negative 5 gives me a negative 15. All right. I'm going to go ahead and continue that on this second half of my expression. I have my positive 12 out front. I have an x and a positive 3 on the inside of my parentheses. I'm going to go ahead and say, okay, positive 12 times x is a positive, I'll put it down as an addition sign, positive 12x. And I have a positive 12 times a positive 3, which is positive 36. Okay, here comes step 3. I am going to take this here, and I'm going to record it here, and I'm going to do what's called justify it. All right, so let's take one thing at a time here. Let's record what our first part of our simplified expression is here. 3x minus 15 plus 12x plus 36. Now, what justification means is this. I need to think about the actions I just took to go from here to here. I need to justify with what I did. So I more than likely want to think of either a property or a lesson that we had during this chapter for justification purposes. Well, anytime you do the rainbow method, right, that was distributive property. So that's actually my justification here. Distributive property. Okay, step 4. Step 4, here's what it is. I'm going to write the word repeat, and this is what we're going to repeat. Step 2 and step 3. We're just going to do step 2, step 3, step 2, step 3 until we're completely done with this chart, all right, with this table. So, step 2 again, I'm now simplifying this part. Now, if you do it the way I taught you to do it, I'm taking a look, parentheses are gone, but like terms are not. I'm going to be combining like terms. The way I taught you to combine like terms was to box my first term here, and then that would be an x term, right? I'm going to box all my x terms, I'm going to circle all my constants. Now, I know some of you guys are getting used to things that I have you do like that, okay? Some of you can't stand it. Well, for those of you that can't stand it, I'm actually saving you time. Because what they expect from you to do, and that this is what we're going to have to do here, is they're going to expect you, instead of doing that, I'm trying to save you guys time, but instead of doing that, they want you to rewrite this whole expression by grouping, or I should say you are grouping, but you are rewriting this, but you're going to move the terms around and make sure that like terms are right next to each other. So what that means is I'm going to take my 3x here and know that my positive 12x here are like terms, and I'm going to put them next to each other. I'm going to take that negative 15 and this positive 36, and I'm going to put them next to each other. Okay? So here's what I'm going to do. I am going to put 3x down, but I am going to take these two terms and flip-flop them. If I take these two terms and flip-flop them, I'm going to have my x's next to each other, and I'm going to have my numbers, my constants, next to each other. So here we go. Now be very careful, because this is what I've been teaching you the whole chapter. You need to keep the sign that's to its left with it. So this term, if you want to, you can even circle the terms separately to make sure you get it right. I'm going to take the positive 12x and put it here. I'm going to take this negative 15 and rewrite it as minus 15 there. And then, yes, I'm going to bring down my positive, or my plus 36. So, step 3, right? I'm going to go ahead and write this right here. 3x plus 12x minus 15 plus 36. Now, justification. What allowed me to do that, ladies and gentlemen, switch two things without getting a different answer is when you switch to things like that. If you think back at the properties, what do you think? When you switch to things like 3 plus 4 is the same as 4 plus 3, commutative property. Commutative property. Now, that is not done. You might want to put a little star next to this. That is not done because remember, there are two different types of commutative property. Now, some people have struggled with this because they say, well, Mr. Wilkins, I would say it's commutative property of addition because I don't think it's commutative property of multiplication. It's commutative property of addition, but the problem is there's subtraction there. And I said, you're right, but we've been talking about this a lot lately. Remember how I've been wanting you to simplify things? I said, get rid of the double signs, right? Well, but I never said, forget about double signs. It's very good to understand double signs. This minus 15, you could rewrite as 12x plus negative 15. Okay, that would be what a double sign would look like. What that means is that is actually addition. That's what allows us to switch them because that is really a plus negative 15. So this is commutative property because I said it's plus negative 15. It's commutative property of addition. Okay, now we did that whole thing instead of boxing and circling or underlining or putting a triangle around it. That's what we did instead. This is what they're going to want to see you use on your test, as well as maybe state testing. Okay, so here's what we're going to do next. I have my expression. Now, remember after we box and circle, usually we combine the x's. We add them up. So 3 plus 12x is 15x. Negative 15 plus 36, well, that's like having 15 negatives and 36 positives. You can use a t-chart if you want. Ultimately, what I'm doing is I'm saying a positive 36 minus 15. So I can come down to the bottom here and just have a little scratch paper work. It ends up being a positive 21. So guys, I write this down as 15x plus 21. Thinking back of what I just did, and I had a lot of people go, oh, like terms, Mr. Wilkinson, like terms. And I said, great, but let's get it correct. We combined like terms. We combined like terms. Now, you have to remember what the ultimate question was in this whole problem. Are these two expressions equivalent? You could say, well, Mr. Wilkins, this is simplified all the way, and you would actually be right, right? There's no parentheses, there's no like terms. That is simplified all the way, but here's an issue. We are looking for it to look like this to find out if these two are equivalent. For me to go from here to something that looks like that, I have to use yesterday's skill. I have to factor. Right? We talked about this looks like a distributive property problem. This is simplified, but this is what we have. We have to work backwards, and that's factoring. I take my 15x plus 21, and I'm going to go ahead and factor using yesterday's steps, right? We have a 15 and 21. Well, 15 doesn't go into 21. Let me really quickly find out what the greatest common factor is. These are pretty small t-charts here. 15 is 1 and 15. 2 doesn't go into it, but 3 does. 3 times 5. 4 does not go into it, but 5 does. But we already have 5. 21 is 1 times 21. 2 doesn't go into it, but 3 does, because I know 3 times 7. 4 doesn't go into it, neither does 5, and 6 doesn't either. But guess what? 7 does, but we already have it. If I look at all of these factors here, the greatest common factor is 3. So I take this, I factor out a 3, I put my parentheses, I say, well, what's left over here once I factor out or divide out a 3? Well, 15 divided by 3 is 5, right? You can look here. 5 with an x left over. Positive 21 divided by 3 is a positive 7. And so I take this and I write it right here. 3 times and then 5x plus 7. My justification, or the skill I just used, was I factored. Now comes the very last step, and that is step 5. Don't forget, of course, we did this whole thing to work towards this question here. Are these two expressions equivalent? What's the answer, guys?
Yes.
Okay. We have yeses and nos. If you said yes, here's my reminder. You need to pay close attention to the fine details. Who could tell me why is it not? One has a negative or a minus 7. This one is a positive or addition of 7. So the answer, ladies and gentlemen, is no. All right. All right. Questions?
How you put the justification, would it always be that way? Or like 1 and 2? Like how do you grow distributive infinite?
No. Sometimes you won't have to use certain properties. Other times it might be different properties or different skills. But that is pretty common, what we just did. A lot of them are common, at least for this chapter. Okay? All right, guys, other questions? Okay, here we go. Problem I want you to try it on your own. Okay, there are some talking, so I'm assuming. Any questions? This is your chance before I let you try one. We're okay? All right. Problem number 2, go. Problem number 2, go. All right, checking in. How many of you need more time? All right, I'm checking you guys in about another 30 seconds or so. Okay. How many of you still need more time? Okay, those of you that are finished, you can go ahead and start on number 1. Okay, it's very similar. Maybe even a little easier. Okay. Okay, check it in. How many of you still need more time on number 2? Okay, so listen, I am going to give you a little more time than I usually do because you guys have all 6 of these boxes to share, right? So basically 6 answers, and then you also have to answer this one up here. So basically 7 answers. So make sure you take your time. I'm going to give you a full minute to turn to your neighbor, share all of them, discuss if you guys disagree with each other, see if you have any questions. All right, 30 seconds, go. I'm sorry, a minute to go. Just a minute.
So one question I got was, and then so for my steps, I did distributive property and I got 14 minus 1x minus 4. This third one, for this step, I got commutative property of addition. I got 21x minus 14 minus 4. Then I combined the like terms and got 21x minus 18. I solved these 2 and I knew my answer.
How'd you get there? Okay. I also got no. And for my first one, I got 14 minus 21x minus 4, and it was distributive property. Question, did you find out which distributive property it was? Because I couldn't find out what it was. I couldn't find if it was addition or... Wait, no, distributive.
For commutative?
No, distributive.
There's no distributive.
Oh, yeah.
Were you talking about there's commutative property? It was commutative property of addition because you could still like put in parentheses like plus, you know.
And then for my second one, I got 3x plus 12x. Oh, no, sorry, I'm wrong. I got 21x minus 14 minus 4, and I got commutative property of addition. And then for my final one, I got 20x minus 28, and it was combined like terms, and I went up.
I think this is wrong because if you add 14 plus 4, that would be 15. Because there's no.
Oh yeah, my
other-
bad. Sorry, 18. My bad.
Okay.
And yeah, I compared those 2, and they were wrong.
I'm going to kind of reel you guys back in. I know you guys, there's a lot of discussion going on. I would normally choose a seat here, and that's what I've been doing in my classes, but we took a little long on that, and you guys had some good discussion, so I didn't want to interrupt it, so I thought that was helpful. But I'm going to go ahead. Let me go over this with you guys, and then I'll let you ask questions, because there are probably a lot of questions out there. So here we go. 2 expressions equivalent, so we have 2 expressions. Now, I'm going to take this, I'm going to rewrite it over here. 7 times 2 minus 3x minus 4. So, when I look at this, I'm thinking parentheses, like terms, they're both there. However, I'm going to get rid, you always get rid of the parentheses first. Use your distributive property. So, I'm going to go ahead and multiply 7 with what's inside the parentheses. So, 7, a 2, and a negative 3x. So that would give me 7 times 2 is 14. 7 times a negative 3x is negative 21x. Now be very careful. If you got a negative 28, you're getting rainbow happy. All right, remember, you don't loop this to the negative 4 because that is not in the parentheses. The 7 is only being multiplied with what's in the parentheses. Okay, that means you're just bringing down your minus 4. I'm going to go ahead, record that in here. 14 minus 21x minus 4. And that, of course, I just use distributive property. Okay? Now, remember, again, I need to combine like terms here, but with this particular problem, they don't want you to box and circle. They want you to use the other strategy. They want you to rewrite it with the terms next to each other, the like terms next to each other. So I could do this a couple of different ways. I could flip-flop these to get the 14 by this, by the negative 4 here. Or I could flip-flop these two and get the negative 4 by the 14. It doesn't really matter. I don't know. For the sake of this problem, let's go ahead and I'm going to flip-flop the negative 21x and the negative 4. If you want to just circle those two terms to help you, feel free. So I have 14, a positive 14 up front. I'm going to bring my negative or my minus 4 over here and bring my negative or my minus 21x here. Record it. 14 minus 4 minus 21x. We just talked about this last time, right? I know they're subtraction signs or negative signs, but it is like having a negative 21x plus negative 4. I just used, because I flip-flopped them, because it was ultimately addition, I use commutative property of addition. Last, I'm going to go ahead, I'm going to combine like terms. So, here we go. 14 minus 4 gives me 10. The negative 21x, there is no like term with that next to it, right? So it's just minus 21x. So I have 10 minus 21x. What I just said I did was I combined like terms. Now, the last part, right, is to take a look up here. Well, some people might say, well, Mr. Wilkins, that's not the same. But it is, right? Why? Because this is a negative 21x, negative 21x. Positive 10, positive 10. Now, this is truly written correctly up here because the constant will go on the far right. Okay? It has the same value, though. So, are the two expressions equivalent? And the answer is yes. Okay? All right. Questions on any part of that? You do need to answer the question. So on your test or on some other worksheets, they may not even ask that question. You have to just be careful with that and look. They do ask it here. I know for sure that you'll see a lot more of this coming up, being able to solve it and justify. On the worksheet, on the answer key, yes, that's why we're doing it. So that is step 5, right? So make sure you answer. Okay. No, we'll break it up. Okay. Yeah, because if there was all or nothing, right, you'd have only 5 problems here, and so we'll break it up. I'll show you guys. Just do everything like I'm telling you, and I'll fill you in on Monday. Okay, here we go. Let's go ahead. I just want to look at 4 and 5 really quickly. We're not going to do them together. Ladies and gentlemen, these are exactly the same thing we just did. Here's a nice part. Well, this part over here with number 4, they have a bunch of decimals. All right, not a big deal, but here's a nice part is they actually did the whole problem for you. They just didn't put the justification. You have to see what they did from here to here and write the justifications. Okay? Down here, same kind of thing. Okay? But they actually go back and forth. So these 2 rows are justifications. This one, they're telling you what to do with that, and you have to write the answer here using that. Okay?
So for number 4, you don't want to have work?
You won't need to do the work. They already have it for you. All you have to do is justify it. All right? Other questions, guys? Okay, let's go ahead and flip to that next page. All right, here we go. Game day special. Let's go ahead and take a look and close read number 1. you are volunteering at the
Snack
bar for your school football game, you need to create to display the game day special, which includes a hot dog, bag of chips, and a drink for $3.75. Okay, so here's your poster. Okay, this isn't very hard. I'm just going to show you what's expected for you, how to fill this out. What they're wanting you to do is write basically separate expressions. Okay, so here's what we're going to do. Let's focus in. These are your a la carte. So if you were to buy just a hot dog, it'd be $1.85. Just a drink by itself, it's $1.15, and so forth. Okay, obviously the cost is of the whole meal. Now, what happens if we buy 2 meals or 2 specials? Okay, so here is what they want you to do. If we were going to buy 2 hot dogs, one hot dog is $1.85. What would we do to find out how much 2 is?
multiply.
You could add by 185 plus 185, but that's going to be very hard when you get to 6 of them, right? So what's better idea is multiply by what? 2, right? So here's what you're doing. Step 1 is you're just going to go through here and you're multiplying the price of the item with however many you're going to buy. So in this case, I have that. I have drinks would be 2 times 1.15. Chips would be 2 times 0.75 for 75 cents. Okay, step 2. Here's what they want you to do. You're creating an expression is what you're doing. So if I needed to find out, not knowing that, if I needed to find out the total cost of all 3 of these put together, what would I do with these 3 here? I would add them, and that's what step 2 is. I'm going to add, and of course that would give me my answer. So 2 times 185 plus 2 times 115 plus 2 times 75 cents. Now listen, on this total cost, you can do all this if you want. I'm actually okay with you grabbing a calculator and punching in 375, but 2 of them, right? So you'd multiply 375 with 2. And my final answer is 7.5, which is, of course, $7.50. So that would be step 3. Okay? So you're going to do that with all of these rows. Okay? So if you take a look at B, what's the total cost if you purchase 10 specials? All you're doing is you're writing a row for 10 specials, but they just don't give you a row. They just want you to write the expression just like you did up here on all these and write the answer. Okay? That's what they want you to do there. Okay, C. This is a little bit of a challenging problem. Okay, but we have talked about this a lot in this chapter. Okay, and a lot of different homework assignments. So read that carefully. It's asking of an easier way to solve what B would be up here. Okay, that's what they want you to write, a new expression, a different way to solve it. All right. All right. Here's what else I want to go over. I want to go over this back page. Now this back page is even more important because this back page is you're going to see a problem just like this on your test. You'll see it on the practice test on Monday. Okay, just like this on the test. So we need to make sure you know how to use all the skills that we've talked about to solve this. So let's take a look at the story up here. Let's close read that. Here we go. Aunt Lulu is hosting a party at Luna's restaurant and reception hall. A flyer that the graduation reception is below. So here's a flyer. Now listen, this is important, yes, but it really isn't important. Here's what's important. You can even box it in if you want. This is the important information at what it's costing Aunt Lulu to throw this party. Now, here's a chart. So if she is going to get 5 guests, here's what you're going to do. Step 1 is you're going to find out the dinner price for 5 guests. Well, this is just like the hot dog problem we just did. If it's 5 guests, if you look here, here's the price of the reception hall, but look at this. It's a unit rate of $40 per guest.
That's a lot.
Ladies and gentlemen, to find out the dinner price for the guest, if it's 1, it's 40, but it's not 1. I would take 5 and multiply it by 40. Find out how much dinner is going to be for 5 guests. You have to. It's not $40 for all 5 of them. It's $40 per guest, right? So it's 40 times the 5.
That's a lot of money.
Now, step 2 is the booking fee. The booking fee is a one-time fee for the hall. It doesn't matter how many people show for her to rent the hall. It's $105 up front. It's one-time fee, a flat fee. That means that I'm just recording it as $105. Now, step 3. To find out my total cost, I need to add these 2 expressions. Now, if we simplify this could be mental math. 5 times 40 is 200 plus 105, and we get 305, and that would be, of course, what you can consider step 4. Write your final price. Okay, now, when you do this, here's what you're doing. Our eyes are up here. Thank you. Here's what you're doing. You are recording this down, but instead of 5, it's 8 guests times 40 plus the flat fee of $105, and you're going to solve that. Now, here is what you need to know. B says write an algebraic expression to determine the cost. Ladies and gentlemen, we now know an algebraic expression requires you to write a variable. So here's what it tells you. They want you to let G represent the number of guests. Take a look at this expression for each one of these. It's exactly the same thing each time, except where does the number of guests go here? On the outside of the parentheses, multiplied by 40. So what they want you to do is rewrite this expression that all of these are going to match, but put G where the number of guests go. Okay? So that should be pretty easy. Then what you're going to do is you're going to answer C using that expression you get for B. Okay?